All right, so now we're at question 57. Which of the following figures have an area greater than 40 centimeters squared? Okay. Formula for the area of a triangle, 1/2 base times height. So for part A, all you need to do is take the measurements and substitute them into your formula. The base is 8, and the height is 9. Half of 8 is 4. 4 times 9 is 36. Yes, 36, and it's in centimeters, so it becomes 36 centimeters squared. That's not greater than 40, making A not true. B, a square has a side length of 7. Well, for the area of a square is S squared. So 7 squared is 49 centimeters squared, which is larger than 40. Making B a true an answer choice. A rectangle has a base of 14 and a height of 3. So for the area of rectangles, it's length times width. So you have area equals 14 times 3. That's 30 plus 10 times 3 is 30. 4 times 3 is 12. 30 plus 12 makes the area then 42 centimeters squared, which is bigger. Parallelogram. So for the area of a parallelogram, has a base of 5 and a height of 6. 5 times 6 is 30, making this one not true. A trapezoid, area equals half height, base 1 plus base 2. Half, the height is 5. One base is 8, the other one is 10. Half times 5 times 18. Well, it's easier for me to do half of 18, which is 9 times 5, giving me 45, which is larger than 40. Question 48. A politician running for mayor in her city wants to know her chances of winning an upcoming election. To figure this out, her campaign team wants to ask a sample of people in her city who they will vote for in the election. What method is likely to give the campaign team a random sample of the population? Ask all the people who live in the particular neighborhood. If you're asking all people, you're not asking random. You're not just asking a random amount of people. Ask people who live in different neighborhoods throughout the city. That's a possibility. To ask a sample of people in the city who they will vote for in the election. Ask people who take public transportation. Well, if you only ask them, what about the people who don't take public transportation? Not A, not C. And then it says here again, ask all the people who shop at the same store. That's a little bit more specific. Leaving you with B. Elaine is the manager of a small toy manufacturer. Her company produces 2,500 toys per week for shipment to retail stores. Elaine wants to know the percentage of toys her company produces that are defective. Which of the following methods would provide Elaine with a representative sample of the toys? Assign a number to each toy, randomly select 100 numbers, and test the corresponding toys. Make sense? I agree. Test the first toy produced each week. Her company produces 2 toys per week, so only the first toy. That's not going to give you a good method. Select the first toy produced each week, each day of the week, and test them. Only the first toy? For each day, randomly pick 15 toys produced that day. There you go, random selection. Test all toys produced on Friday. What about Monday, Tuesday, Wednesday, and Thursday? Okay. Leah. is an administrator for a large school district. She wants to know how many hours students spend on homework each week. She asked the questions to 250 randomly selected 8th grade students. The results are shown in the table. Which of the following inferences about the 8th grade students in the school district are valid, which means it's good data? There are more students who spend at least 4 hours per week on homework than students who spend less than 4 hours. So if it's at least, that means it's 90 and 28, which makes it 100 and 120. 90 plus 20 is 110. That makes it 118 people. Oof, this is 128, much less. A is not true. About 11% of the students in the school district spend at least 6 hours of homework per week on homework. Well, there's how many students did she ask? Good answer, 250. So she asked 250. How many students spend at least 6 hours? That's 28. We need to figure out, is 28 over 50 equivalent to that 11% that they're talking about over here, over 100? Okay, so divide it by 2.5. To get from 250 to 100, divide by 2.5. Do the same thing at the top. Now come to the side and say, okay, 2.55 into 28. Move the decimal over, add a placeholder, and put the decimal up. 25 can go into 28 ones. What is that? 3 ones. 25 is 5. 0, 11.2. So is that about a guess or a best guess? That's close? Yes. About 50% of the students who spend less than 4 hours per week on homework, about 50% of the students who spend less than 4, 2 to less than 4, spend less than 2 hours per week. About 50% of the students who spend less than 4 hours per week on homework spend less than 2 hours per week. That doesn't even make sense. Less than 2 hours. About 50%. Well, 88 plus 44 is 12. 132 over 250 divided by 2 goes in there 6 times. 66 over 125. Is not less than 88 is not 50%. About 1 of every 3 students who spend at least 4 hours per week on homework spend at least 6 hours per week. So that means 1/3 of the students. 1 of every 3 students who spend at least. No, not a true answer choice. All right, 61. An electronic retailer receives a shipment of 6,000 CDs to distribute to its stores. A quality control manager inspects a random sample of 40 CDs and finds that 2 are defective. There's my inspection ratio. Out of a total, 6,000. How many CDs in the shipment are likely to be defective? Cross multiply. I'm going to simplify this to 1 over 20 equal to x over 6,000. Okay, so 20 times what gave me 60? 3. Add 100. Add the 3 zeros. is 3. Add the 2 zeros. So times 300 makes x 300. So about 300 of the CDs, of the 6,000 CDs, are defective. All right, 62. Sally works at a frozen yogurt shop that has about 2,500 customers per week and wants to know how many people like vanilla frozen yogurt. She asks the question to 40 random selected customers. She repeats this process 2 times. Sally finds that 14 people said they like vanilla in the first and sample, and 18 in the second, and 12 in the third. What is the difference between the highest estimate and the lowest estimate of the number of customers per week who like vanilla, who like frozen vanilla? So for the first sample, she did 14 of the 40. Multiply that by 2,500 over 1 is equal to 875. And I know that because I multiply across, but the answer keys are next to me as well. Second sample, 18 over 40 times 2,500 is equal to 1,125. Third sample, 12 over 40 times 2,500 is equal to 750. So, let's ask what is the difference between the highest estimate? So we have 1125 minus 750 is equivalent to 375. The difference between the highest estimate and the lowest estimate is 375.